we'll start by saying, Andersen, thank you guys for sponsoring the event. Thanks for having a booth at Build Show Live. This is pretty amazing that we're all here from where we started. I think it's awesome. And thank you guys at Andersen for deciding to have me in the booth. And thank you for putting me on a poster over there. Oh, I didn't even see it had a quote from me as well on it. I wonder if that's something I said or if that's something that Ellie just wrote. Okay. So this is just one house. So all we're going to do today is talk about one house. If you missed the first slide, one of the metrics that Passive House judges performance is just kilowatt hours per square foot of electricity usage. And so we got electricity numbers from this house. This house is basically 30% more than what Passive House allows for, but we didn't do that awful much more budget-wise. We didn't do that much awful more energy efficient-wise. We just were deliberate with everything that we did on this project. So this is a home market job for us. My company, if you don't follow our content on Build Show, we build custom homes in Columbia, Missouri, and we build in the Kansas City market now as well. And this is in the Columbia, Missouri market. So this is actually only like 3 miles from our office, 4 miles from our office. So this one got a lot of attention because it was easy to get to. And we'll start with, I didn't get a picture before we started knocking the other house down. So it looks like this, had I gotten there 20 minutes earlier. The important part for this, the reason that this is here is the size, the scale, the shape. Most of what happened with this house and the funky things that we'll talk about design-wise with this house are all lot-based and all driven by these people didn't want to move out of this neighborhood, even though they live next to weird rental properties that are multifamily and things like that. And they wanted to stay on this property. And the first time they called me, they were like, we just want to renovate this house. And I walked into the house and I was like, you have like red clay foundation that I can push my hand through some of the red clay block because it's so deteriorated. We're not interested in renovating this house. And then 6 months later, they came back and said, we want to tear this house down and build a house. And I was like, that's great. We're on board with that. So we started by working with them on a design with a local architect. This is not a Steve Basic house, but this has a lot of the same details that we normally would do with Steve. I would make an argument that most of the details that we do with Steve are based in, can we get it at the lumberyard? Can our carpenters do it because they know how to cut and tape and use a caulking gun? And then does it not break the bank? Because somebody has to pay for these details. And we're not building for multimillionaires most of the time. I don't know if the clients gave me approval to put their floor plan up, but they're not going to see this. So the house is 1,760 square feet on 3 floors total. So living space on the first floor is mudroom, and we're counting the mechanical room as conditioned space. It has a tuck under garage, meaning when you pull in on the ground floor, it's underneath the rest of the house. The main floor has office, living, kitchen, no dining room, and the half bath. Does anybody know the difference between a half bath and a powder bath? Whether or not the house costs more than $1 million? It's the truth. I have a half bath. And then the upper floor, the architect still labeled it a powder bath, even though it has a bathtub in it for some reason. 3 bedrooms and a landing. That landing, even though it's like 6.5 by 6.5, still has a recliner and like a reading nook in it. So it's a very small house, but you can see that it lives slightly larger than that just because of everything being laid out kind of well. The footprint on the house, if you didn't read it, is like 24 by 32. That's small. we have some living rooms that are like that size, you know, like, so we're talking about really, like, if we screw it up, it's going to have a big impact because there's not any like, oh, we get to overcome that by scale or anything like that for that matter. It's a good, you can get a sense of the lot. They do run a chicken coop off of the electricity. So when I do say that we're 30% over passive house, I'm going to tell you that we're probably chicken coop over passive house levels of energy efficiency. They raise meat chickens and meat rabbits. So they're not as weird as you would think. Maybe they are. Brent's shaking his head they are. But you can see how close the lot lines are. I will also say the first time we dug the foundation, and the footings, we were about to pour concrete and I went over to double check everything. And I was the one that had laid out the foundation. And when I went to pull measurements to double check it, I realized that I had pulled off the street instead of off the lot line, and we had to redig everything because I was not in the correct spot. So that was a nice little, hey, guess who's spending an extra $5,000 to redig part of the foundation and refill footings and everything. So just because I get to be the one to stand up here doesn't mean we're any better than anybody else necessarily. So traditional cast in place, 9-foot basement so that we have enough room to get cars in. We're about 6 or 7 feet in the ground naturally at the back of the house. We ended up being 8 feet in the ground after grade, so we just raised everything up. Nothing particularly fancy about the cast in place, although if you heard me give the water management discussion over here this morning, we take water management below grade super serious. You're never going to get another chance at this. Well, you can if you're willing to haul equipment back over there and disturb a deck and a driveway and grass that's been growing for years and move trees and shrubs and things like that. So why don't we just do it right before we cover it up with tons of dirt? So we have a fluid applied membrane and then a dimple mat to relieve pressure and a term bar, and you can see the vertical pipes are clean outs so that we have access to our footing drain. I also forgot to mention, I don't care if I don't get all the way through this. You guys can raise your hands and ask questions. You're not going to bother me, just so we're clear. I don't think Ellie cares if I get all the way through it either. So the important part here is we have continuous insulation above grade in the form of zip R, and we'll talk about that in a minute. People have like a slight panic when we start talking about doing continuous insulation. And they're like, well, that's going to be expensive. How are we going to do that? And I think one of the things that they forget is that you already have continuous insulation on your building, most likely, in the form of like insulation underneath the concrete slab in the basement or insulation on the foundation walls. So I didn't get a picture before they poured the foundation or the slab. We have insulation underneath the entire slab. And then we have here a vertical leg before that slab was poured so that it's thermally broken from the exterior wall. That insulation is just a small piece put in place because the reflective coating on this halo subterra is so shiny that it actually will reflect and burn itself if we don't like put it up right as we're covering it. So we just put a little leg in to make sure that it is there before we cast the slab. All of our air sealing details that we normally would do on any of our much more substantially costly houses come into play on this project. So what we're looking at here is the base plate for our walls, our sole plate or our sill plate. This is the bottom side of it. We have regular sill sealer. Sill sealer is not an air control membrane. If you have some on your job site and you think otherwise, hold it up to your mouth and blow through it. You can blow through it. It's air permeable. Also, fun fact, it's not required by code if you use treated plate. If you don't believe me, it's in the code. You can look it up, but try telling that to your building inspector. So we're using a bead of acoustical sealant between the sill sealer and the plate to stop air from leaking between the sill sealer and the plate. And then we're using a piece or a bead of acoustical sealant between the concrete and the sill sealer. And they're on opposing sides of the 2x6. rather than both on the same side, so that our plate doesn't sit wonky one way or the other once we go to stand a wall up, right? The reason we're using acoustical sealant. Acoustical sealant never gets hard. That way it doesn't transfer vibrations. It also doesn't get hard and then crack and allow air to leak through it. We use USG quite often. They make one that isn't as runny as Trimco. Trimco, in my opinion, is probably a better product for this, but if you've ever even handled an unopened tube of Trimco acoustical sealant, you have clothing that has Trimco acoustical sealant on it already. Remember the tuck under garage on that half of the foundation? We're sealing between that garage and the space above it, and we're going to seal that area by using zip on the ceiling of the garage. So at this point in framing, before we start setting floor joists, we have a flange, at this point we're calling it a flange, of zip. Now, if you're paying super close attention, we're going to set floor joists on the top of that, and then we're going to put zip on the bottom side of them, and we're going to tape that. Well, that means that should be green facing down there. That's a case of the framers not knowing what they're doing, but the project manager explaining it over the phone that they needed to put that on there and it being on the plans, but them not understanding. The tape still sticks to the brown side. It's just then we now have to have that conversation with the clients of why this part's brown, that part's green, all that sorts of things. Talk about a pain in the butt. You could also see the continuous insulation at this point now, before we frame those interior walls. That sheet comes down and sits on top of the sheet that was already there, right? Hi, Matt. So now that continuous insulation, that's a super common thing, super common detail that is scary when we talk about doing it on our above grade walls. Everybody's putting that sheet foam in down there. This house happened to be T-studs. The T-stud is maybe not on the market now, so don't get too excited about it. I don't think I would make an argument one way or the other if you should or shouldn't use them based on their current status as a company. However, it is a thermally broken or mostly thermally broken stud. It's a truss that all they're doing is standing up. They're opposing directions. So one 2x3 this direction, one 2x3 this direction, and it gives a multi-directional strength axis to the framing member. So it's stronger than something that's just this way or just this direction. And because they put them in a jig like this, and then they dowel them together, they're straight when they come out of there because they're in tension against each other. So we like them when we could still get them easily because they're straight, and they allow us to have better insulation in the wall. And in this case, we attempted to use them as headers because they provide engineering for a header assembly, and then you can get a better insulated header because you're using less wood in there and there's framing pot. It's a little challenging. If your framers aren't paying close attention, the header detail is pretty difficult that way. It also means you have to wrap the inside of that jamb opening with something that's solid to keep your blown-in insulation from just falling out of that RO. The other thing that we had here was we had zip R as well. So if you're paying close attention, we have a thermally broken stud, but we also have a thermally broken insulated sheathing. It's a belt and suspenders idea to thermally broken wall assembly, I guess. We're upping the ante a little bit. The clients were wanting to not pay an arm and a leg. The idea of them investing in the idea that they're going to tear down a house that they had paid off, that they've lived in for a decade already. They want to stay in that neighborhood. They want to see the neighborhood thrive. They're staying here the rest of their lives. They're okay with paying a little extra for insulation with the idea that they're going to have a better benefit in the long run. So this is not a big deal for them to say, well, we're already paying for T-studs, but we'll also pay for zip R. That's one that we get pushback on quite a bit, where it's like, well, don't they do the same thing? They do. They do it better together than they would separately. It's probably a little overkill, and I'm okay with that. I understand it. I also like the idea that they're straighter because we use engineered studs for a lot of things, because in this house, if you remember the floor plan, it's like window, cabinets, and then we're back up to bedrooms. We like engineered studs on the bedrooms. This bump I'm not sure if I have a good picture of it anywhere else. The house is in a historic neighborhood. When we went to tear it down, we got a plan review back after we had a permit issue. And they said, oh, by the way, this is a historic neighborhood. Your 32-foot long wall down the side of the building, it's too long without an elevation change or a coastline. And I was like, what? And they're like, they didn't used to build houses with big long walls. There would be like a change in elevation or plane in the wall. So you have to have a change in plane. And I was like, I talked to the chief inspector and I said, can you show me where it says that in the like neighborhood code? And he showed it to me and it just says change in elevation for like width, like horizontally. I was like, okay, what's the minimum change in elevation? And he was like, well, what do you mean? And I said, is an inch enough? And he went, I guess so. So we used 2x8 studs on both sides of the house to buck out a section of windows. On the inside, the wall's flat. You can't tell anything happens. We bumped a 2x8 stud on one side. We bumped the stairwell studs on the other side. And then all we did was add a trim board and butt our siding to it. And then we didn't have to change foundation. We didn't have to change anything on the inside. There's no extra trim on the inside. All we did was add 2 pieces of hardy trim on the outside and some 2x8 studs. And they got a little added insulation in those sections. Sometimes the simpler solution is the better solution. When we start talking about things like passive house, you rarely hear that sentence. The simpler solution is the better solution. We didn't do the T-stud headers on the second floor. So in other words, by the time we got done framing the first floor, we decided not to do that anymore. It was a little easier to just do this. And that's the affectation of, well, we have the zip R. Let's not deal with that anymore. That is the most poorly stuffed rock wool in a corner that they were going to have a hard time getting to. That's why I had that picture, actually. I didn't think about the fact that that was going to be in there. I should have cropped it so you wouldn't see that. No, but there's T-stud there. You can basically insulate that whole cavity. I think we pulled all that out and then blew it in later. There's another shot of the T-stud headers as well. Another good one. So when we talk about the house being fairly cost effective, even though we're using T-stud, even though we're using Zip R, which are premium products, there are 3 places that there's spray foam in the house. Right? Rim. Rim joist is like the only place that you can't insulate with anything except for spray foam, in my opinion. Like you can stuff it really well with the bat, you can net it, and sometimes you can do a good job blowing it. I think it's the best place to make an argument that spray foam is the place to use it. Spray it and be done with it. And if you have like this where there's 3 floors and you're trying to lock in your trusses up top to prevent wind washing from your soffits, that's a great place to go ahead and do that. Our insulators will even like box that in with cardboard and then spray foam it. And then there's not even expensive framing that has to happen there for us to do wind washing protection and things like that. And it's like we're cheating the system. I know it's cardboard and that sounds like garbage, but they're backing it with spray foam, and then the spray foam is the structure. And then we have soffit material on the outside that's protecting all that, and you can't see it or feel it or touch it or get to it or anything like that. The rim is the place that now we don't have to worry about. So you can see the elevation changes there. You can also see our trusses. See how the trusses have that indent in the bottom of them? There's a better shot of them probably. There's the best shot of them. So this was the first time that we tried this on a house this small. Side to side is 24 feet. This is the upper floor. We got to feed 3 bedrooms and a bathroom. So we have this, we call it a pizza box cassette unit that's in the hallway. We made an agreement with the clients that they would not yell at us when we have to cut the ceiling of that hallway open to replace that unit. But we want all of our mechanicals inside the building envelope and inside the insulation, inside the air control layer. So we build a plenum into the order of the truss. We sheet the top of that plenum with zip, so that we can mount things to it wherever the heck we want, right? And then we used Myrex to cover the two sides, and now our air control membrane is on top of our HVAC. Our duct runs go out to each room. There's the air control membrane finished. And then after the fact, we went in and infill framed 2x4 ceiling flat the rest of the way across there. We have a flat ceiling on that floor. We have mechanicals going to each space. And very simply, very easily, everything's inside the envelope. Nothing's leaving the envelope. We're not trying to push 70-degree air through a 140-degree attic. It's all inside of our envelope. It's all inside the conditioned space.
So how do you do that when you have a longer, bigger soffit?
Question is, how do you do that when you have a bigger soffit? Like you have a wider house?
Yeah, wider house.
Well, you can put bearing points in the middle of that rather than hanging across. Here we actually have props that go up and hang from the trusses, the 2x4s. And then when we built partition walls, they're holding up the 2x4s through there. Yeah. And the wider you are, in theory, the more space you would have. We fit all that into a 14-inch bump. And I think we priced the trusses both ways, and it was like $300 for the house to have them do that to the trusses. They don't care. The truss manufacturers, cost them almost nothing to do that stuff. It's all software. If you haven't heard me talk about air sealing before, it's one thing per hole. Kevin's giggling because normally there's a dirty joke that accompanies that. If you take a bundle of wires or all three of those pieces of the line set and you cut one big hole and then stuff them through there, you're not going to be able to air seal those together. I will agree with you that if there's two wires running through one hole, you can probably air seal that just fine. But if you tell your electrician that, he hears I can air seal 4 holes or 4 wires in one hole. So if you just say one thing per one hole, then that's fine, and he'll do it. He won't do it the first time. Let's not. This isn't Disneyland, and Kennedy's not still alive, and flowers don't bloom year-round. There's our tuck under garage detail. This is one that our framers have a hard time with a lot of times, and honestly, I don't understand why, but the way I've decided to explain it to people is if we didn't put a garage door on that, it would be a carport. And then you would have no problem understanding that it's outside. Just because it has a garage door on it does not mean that it's part of the house all of a sudden. So by putting a garage door on it, that doesn't mean now that we share the air in that space with the air inside the house. Now we could do this with Myrex like we had Myrex on our trusses upstairs, but for us, this is a very simple material that we have on site that is a little more cost effective than the Sega Myrex. And we have that framing flange that can go in and be nailed up before we build our wall. It's easy to tape all that together. And then all of this is of higher consequence than leaking from the second floor into the attic. Like second floor to the attic, that's an energy penalty. Potentially it's air carrying moisture and maybe mold at some point if it has enough moisture and there's temperature differences. Here, nothing that I'm storing in that garage do I want sharing with the air in my house from health reasons as well. This is a little higher risk most of the time, so I would say I like a little more durable there. There's another good shot. It's not supposed to be faced insulation. That was why I took that picture, to show someone that those bats were not supposed to be faced. We don't put faced bats in below grade applications. So we just pulled the facer off and left the bats. That wall is up against the concrete wall. So that's the wall that doesn't adjoin the rest of the house. That's the cheapest insulation we can buy to put in that cavity to just provide a little bit of protection for that space. If we were really cheaping out, we would have found a way to just stuff the part that's above grade, but we're not going to cheap out that much for them, if that makes sense. There's the other example of one thing per hole in that system. We have to run everything through that ceiling that's coming down. At my personal house, I pushed everything through the ceiling of the garage and then ran it in conduit on the ceiling because I was the one bending conduit and running everything. And the cost wasn't the issue. It was just that I didn't want to air seal all those holes. So I air sealed one wire and then ran everything around the way I wanted it. Here, the electricians poke it down where we want. We air seal it. We air seal the top side of that box as well. And then we can have everything that we need down there. You're all totally allowed to ask questions, except for you. Just so we're clear. Just to be on the safe side. So, window package, and the reason that I get to talk in Andersen's booth is that this house is Andersen 100 series windows as well. So, all of our window install methods, none of that changes depending on what windows we have or anything like that. Everything is still, if we ever get a window leak, we want that sill slope to the outside. We want the entire unit waterproofed. When we started talking to the clients, the conversation about windows went multiple different ways. Number one, we want black windows. Okay? There are only a few manufacturers that make black windows that we trust. Number two, we don't want to spend the money on aluminum windows. Okay? So then we're not looking at certain tier of windows. We're looking at a different tier of windows. And they were like, we'd be okay with vinyl. Well, we're not putting in black windows that are vinyl because they shift and they move and they go all over the place when the heat hits them. I don't care how many times you want to promise me that that's not going to happen. There's a reason why they don't make them. Not very many people make them. I've painted a piece of PVC black and then measured what happens to it. And working with these guys and the Fibrex windows, have anybody used the Andersen 100 series windows? Okay. So if you haven't used it, have you ever installed one of the Andersen patio doors? Okay. So the Fibrex material has been in the patio doors since the 1980s. Okay, there's some people over there shaking their heads. When they first started talking about this product, I was like, oh, that makes perfect sense. Like, if it's been in contact with the bottom side of patio doors for 40 years now and they're not having issues with it, why didn't they think of that earlier to make windows out of that if it's dimensionally stable and it doesn't rot? They're all looking around now. But we have a selection process when we're talking about our scope of work for this project already had, prior to window selection, one ACH 50 or lower for air leakage standard. That meant that we had to apply design-wise to the project. Some of these windows are probably not going to open. Some of these windows are going to be, or most of these windows are going to be casement if they want them to open. The reason for that is not because double hung windows are poor performers or anything like that. It's just nature of a double hung window has at least one more horizontal seam that it has to air seal times two because it's both pieces are moving. We're not going to go that route if we're trying to limit air leakage. We're going to go for things that leak less. Windows that don't operate don't leak because there's no jams or moving parts that get out of alignment over their time or shipping or anything like that. And then windows that are casements have that little cool little latch that pulls them in tight. That's how we're able to get air leakage numbers out of a very cost-effective window in this system. And this house did test at course print left. Okay, he gets credit because he's working then. He's taking a phone call. It was below 1. We didn't fail our goal here. There is an entire series on Andersen's website. Making Ellie look. On this house and the process of this house and why we selected these windows as well. You can go and look. There we go. There's some of the numbers off of the windows that we actually picked for this job. U factor is the inverse of R value, so 1 divided by 0.27 is the R value, if you're wondering. Solar heat gain number is pretty decent. And then VT is visible transmittant of light, so 47% of the light is still getting through. Those are pretty decent numbers for a cost-effective window in the US market as well. This is where I don't have good pictures of windows. Our install methods, we're still leaving that bottom flange open, which means all of our air sealing details are from the interior face of the window. Kevin.
Are those mold on site or are they brought to you?
I don't think any of these were mold on site. I think all of these came like that. He's on the phone again. All of these were shipped like that.
Have you had any air leakage issue at the mold?
Not that I know of. Question was, do you have any air leakage issues at the mall? And I have to say, not that I know of.
Could you seal the bottom?
So Andersen allows for a face sealed installation. They're okay with that still. Wait, why am I looking at you? I should look at Cliff. Where's Cliff?
What, you
Yeah. No offense. It's a barrier installation. The challenge with the barrier installation, in my opinion, I'm talking from my perspective, not Andersen's perspective now, is it has to be perfect. If you're creating a line of defense at the face of the front line, it has to be perfect. If I move all that to the inside and I have a like kind of partial line on the outside where I have this N shape that's managing some water to shed, and then I have a waterproof sill that slopes to the outside and I'm leaving it open at the bottom, then I'm allowing for the idea that the window is going to leak at some point potentially, which is probably pretty darn likely. And if it does leak, I've accounted for the idea that it can leak and it can mitigate itself. And my zip is watertight. If the water leaks and it gets to the zip, I don't care. It's outside the building at that point. So I'm a big fan of leaving the bottom open, moving my air and water to the inside, shedding as much as I can. I'm also a big fan of 2-foot overhangs and protected windows when I can as well. Daniel. I can't hear you. Sorry. Do you connect the window frame to the Myrex? So this house only had Myrex on the lid. There was no Myrex on the interior of the walls. We had zip that turned into the openings to protect the cellulose from falling out of the T-stud openings. So our zip tape turned into the openings on the... Are you going to pass out hats?
For the people that ask
If you ask questions, you get a hat. So we had zip that turned into the opening. So we're turning our air and water control layer into the opening at that point. And then we're able to connect the air and water control layer that is the zip to the air and water control layer that is the window with just a bead of sealant at that point on the interior face. Does that make sense? Okay. The other aspect that even though this house, I keep saying cost effective, obviously we are more expensive than bottom of the barrel spec builders. Cost effective for us. Even though we're talking about a cost-effective build, we still have a rain screen. We still have the things that are important to us. We're not going to get ourselves into warranty issues. We're not going to cause water issues for the clients. We're still worried about moisture. But we're doing a rain screen that's 3/8 thick so that we are enough to get convective loop drying. We're leaving it open at the top and the bottom. 1/8 of an inch is enough for a capillary break, but 3/8 is enough to get air movement. Now we're a little tall. We probably should have gone a little thicker. But the problem is, if we go thicker in this case, then we have to trim around every single window because our lap siding is going to stick proud of that like 1.25 inches, 1.125 that you get from the thickness of the window. So we make a concession there because we have a decent overhang. It's just for plywood ripped into 1.5 inch wide strips. It's the most cost-effective version that we can find for a rain screen. And even the deck is mounted to a 3/8 rain screen so that the deck isn't even a rim joist held in tension. Does that make sense? This is the only chart. Nobody panic and walk away right now. 12 months out of the year, it's kilowatt hours of energy per square foot usage for the house. The long and short of it is it's about 30% over what passive house allows for. That's pretty darn good. It's also about, I think that makes it like 60% of what the national average would be for a house of that size. And they didn't totally give up on all of their finishes on the inside. They have custom cabinets. They have hard surface, solid surface countertops. They have decent mechanical systems. They have an ERV. They have a tankless on-demand water heater. They have Mitsubishi HVAC. Mitsubishi? I think it's Mitsubishi. Might have been Daikin. And they even sprung for a very disgusting looking black toilet that you can never tell is dirty, at least. Like when we went to do turnover for the house, I looked at it and was like, I don't wonder if we even need to clean that thing. Like it doesn't, you can't tell that it was dirty or not. They also had the most unique color palette of any clients that we've worked with in a very long time. They were amazing people to work for. I pick at them though. And a purple front door, purple back door as well. When they gave me the colors, one of our carpenters was like, that's gross. And I was like, it's not your house. I think it's great. I think that I celebrate the idea that they have their taste and it's their opinion and they are happy with what they were getting. I was like, it's also helpful that they're the ones paying for it and not you. They do like deep purple. They are those people. Does anybody have any questions? You guys are easy. Okay, now I'll open the floor to Joe if he has any questions. Yes?
Is there a wall assembly or face seal so like wood use the seal block on that method?
Is there a wall assembly or face sealed assembly that I would use for that? I would be okay probably even on this house if we were pushing. I could see a barrier install with the Andersen 100 series. I just think a slight tweak in method and you up your durability. There is more effort in a drained opening, you know, moving everything to the inside. I have a face sealed assembly at my personal house, but guess what? If I have a leak, no one's going to call me to yell or threaten to sue me. Yeah, Brandon's saying, yeah, I know somebody that will yell at you. What? I am married. That's who he's talking about. Brandon knows my wife. He knows darn well I'll get yelled at. Yeah. Anybody else? So the real question is when liquid flash, when tape, right? I think it comes down to geometry and budget. So if we have the budget, period, I would rather use liquid flash. I like the way that it goes into the geometry of everything better. Second, if we have other shapes or forms that we have to conform to, liquid flash works way better. But they make really high quality tapes that if you're paying attention, you can make just about anything work at this point. So my preference is fluid applied, but the budget is not always supported. And actually I put up a picture here of fluid applied. We had one window that we did fluid applied for training, and the rest of the house is actually tape. Yeah. Now go ahead. It was one of my guys. They can ask their questions later.
I know the answer.
Okay. Go ahead, Kevin.
On your window seals, you always flash all the way to the inside? Or
So
is that only because of your T-star that you do?
So the question is, do you always flash your windowsill all the way to the inside? We try to push that windowsill as far in as we can with one piece of tape if we're doing it with tape. And then if not, we try to bring that all the way in past the interior face of the window because we have to make that connection point. And then depending on the slope that we have, depending on the risk of overhang, back dam is a big concern for us too. Brandon.
What do you prefer to see the interior with?
What is the preferred interior seal? I like a fluid applied sealant because turning that interior geometry with tape is difficult. I know that the project managers will say, I don't want you getting that crap all over my windows. So I would rather you use a piece of tape. And then when we use, when we have installations like we've done some Andersen windows that don't have a flange and they have clips, the clips are really difficult to tape over or smear over. So then it's like, well, which one do we really use? You know, there's some challenges there as well. We kind of shy away from putting much insulation in there. There's some stuffed fiberglass in this one with the hope that air will move through it, but we're only climate zone 4. We take a little bit of a ding, we realize that. We use backer rod, and that's kind of all that we're really putting in there. We'd rather manage the water and risk a little bit of potential for condensation at some point, rather than stuff it completely full and create a dam. We certainly don't spray foam anything in there and cause a dam moment at that point. Okay. Oh. So when we're doing backer rod, it's on the interior face, all 4 sides, and that's what's holding our beta sealant in place. So we're making that connection between the window and the jamb, all 4 sides for our seal. Yep. Anybody else? Okay. I'm hanging out for a little bit. Come say hi if you want to. Thank you, guys.